35,000 feet above the Bering Sea.
Anchorage northwest 85.
Confirm that you are aware that we have declared an emergency.
A Boeing 747 is in serious trouble.
Can't do that. There's too much traffic.
We're calling this a red emergency.
Red emergency is preparing for the worst.
The crew can barely control the plane.
It was a very confusing situation. It was something that they had never done in training.
They need all the help they can get to have any hope of bringing the plane and its 386 passengers safely to the ground.
If there's ever going to be a time you fly the perfect approach, it's got to be this one.
Mayday, Mayday.
Northwest Airlines Flight 85 is making its way over the Bering Sea. It's after 5 p.m. Dinner service has ended, and passengers are settling in for a long flight. The massive Boeing 747-400 has just flown over Alaska and is now almost halfway through a 13.5-hour journey from Detroit to Japan's Narita Airport.
Hello, gentlemen. Frank, how are things?
35,000 feet.
Captain John Hansen is a career pilot. He's also a flight instructor for the Boeing 747. 6.5 hours into the flight, he's about to hand over the controls. On long journeys, it's common to have 2 flight crews.
The trip was long enough that we put on a full augmented crew. We had 2 captains and 2 co-pilots.
They fly in shifts to prevent fatigue.
Why don't you guys give me a ding about 20 minutes before you want me back up here, okay?
Mike Fagan, a Vietnam vet with 25 years flying experience, is the fresh first officer.
Everything was normal, and we didn't expect to have any problems. We've flown this flight many, many times.
Frank, I'm taking the lasagna. You get option B. Does option B include starving?
He is joined by Captain Frank Guide, who has over 11,000 hours of flying under his belt. Pilots refer to this aircraft as the Queen of the Skies. It's equipped with a private cabin for the flight crew. Here, Captain Hansen and his first officer, David Smith, will have a 5-hour rest break before returning to the flight deck.
Dave Smith had worked with me, and we were going to read for a while, perhaps nap in the bunk, and wake up for descent to Tokyo.
You sure you're not hungry?
Trust me, I'm good.
Flight 85 is more than 6 hours from landing at Narita.
The aircraft took a dramatic roll to the left. It went from 35 through 40 degrees of bank.
For no apparent reason, the pilots have lost control of their plane.
The airplane took a lurch, like nothing I had ever felt before. And I kind of had to catch myself.
It was a very sudden yawing movement. It's the type of thing you only feel in a simulator when they're doing extreme things.
Captain Guy has only moments to react.
Did we lose an engine? Do we still have engines?
Still have all engines, that's not it.
The lives of 386 passengers hang in the balance.
The airplane was kind of shaking, and I knew the autopilot had been disconnected. It was quite obvious that something was abnormal.
In a matter of seconds, Captain Guy has disconnected the autopilot, pulled back on the control column, and leveled the wings. But something is still seriously wrong.
Frank, you got it?
Yeah, I think I've got it.
If it's not the engines, then we have a problem with the rudder.
The pilots have leveled the plane, but they are still having difficulty controlling it. The warning system confirms Guy's suspicion.
Yaw damper lower.
A malfunction of the rudder system. The rudder controls the plane's yaw, its movements from left to right as it flies. It directs airflow to keep it flying straight. Less than a year earlier, American Airlines Flight 587 lost control of its rudder system and crashed into a neighborhood in Queens, New York, killing everyone on board.
We were very well aware of that, and there had been quite a study done on that. So we had actually just reviewed that event in flight planning.
This plane is in danger of suffering the same fate. Because of its size, the 747 has both an upper and lower rudder. They normally move in unison. For some unknown reason, the lower rudder has deflected 17 degrees to the left, and it's stuck there. The captain tries to keep the plane flying level and straight. He uses foot pedals to control the upper rudder, and the control column to move the ailerons. But he knows it's a stopgap measure that may not work for long.
I've got the airplane and the radios. You get the comm and see if there's a procedure for this.
The COM, or Cockpit Operating Manual, provides a list of procedures for emergency situations.
It says not to remove any pressure from the hydraulics, that's all.
That's not very helpful. Is there anything else? Are any other systems failing?
Not so far.
Hydraulics control several vital components, including the failed rudder. More failures could spell disaster.
How far to Narita?
About 6 hours.
Flying that far without full control of the plane is a huge risk.
P3, get them back.
When you're in the bunk, you're used to hearing the P3 only at times when it's time for a shift change. When you hear it at an odd time, it means come back, because something out of the ordinary has happened.
Anchorage is 2 hours behind us. Call them and declare an emergency. We're turning around.
Anchorage, this is Northwest 85.
But even contacting Anchorage is a problem.
Anchorage, this is Northwest 85.
Air traffic control centers have a limited range. In the middle of the sea between the two continents, the plane is in a dead zone. No one in Anchorage knows they're in trouble. In the cabin, passengers don't know the scale of the problem. Many passengers assume it was only turbulence that caused the sudden jolt.
See if you can reach 19.
The pilots attempt to contact another flight that's closer to Alaska.
Northwest 19, this is Northwest 85.
But the signal is weak.
Northwest 19, this is Northwest 85.
This is Northwest 19, go ahead.
We have an emergency on board. Can you relay to Anchorage?
Roger, stand by.
Okay, let's turn this around.
The plane goes into a very wide right turn.
Anchorage Control, this is Northwest 19. Northwest 19,
Go ahead.
Northwest 85 is requesting an emergency landing. What is
The nature of the emergency.
Hard over, left rudder.
The rudder is crucial for turning the plane around. Without it, the captain is forced to improvise.
We had no idea what the problem was. So Frank was very cautious on using the rudder, which means that he had to use full aileron to control the aircraft. But in the meantime, the aircraft is in a slip. And a slip is when the aircraft is not in a coordinated turn. The tail is off in one direction, the nose point in the other direction. In other words, it's a slip that goes like this.
Like a race car driver skidding through a turn, Captain Guybe is close to losing control.
Let's move it.
What's happening?
We've declared an emergency, and we're headed back to Anchorage.
Indications?
Lower rudder is hard over 17 degrees to the left. We don't know why, and it's not responding. We don't know what else is wrong yet.
It took both hands to fly the airplane. We didn't know at that point whether the rudder was coming apart. All we knew was it was definitely a rudder problem.
This has never happened before. The pilots haven't been trained for this malfunction.
There's no procedure in the comm.
And the manual is of no use.
Well, we're gonna have to make one up.
35,000 feet over the Bering Sea, and an hour and 40 minutes away from the nearest airport, the pilots of this massive 747 are in uncharted territory. For the 386 passengers on Flight 85, the anxiety over the sudden dive has subsided. No one in the cabin is aware of the potentially fatal drama still unfolding in the cockpit. Without full control of the plane's rudder, the crew needs to fly another 1,300 kilometers to Anchorage.
Frank was the junior captain, I was the senior captain. And when I saw him battling the controls, I decided that I was gonna take over.
Hey, Frank, you've done a hell of a job, but I think I better take over now. If anybody's gonna ding this thing up, it's gonna be me.
I have no problem with that.
Okay.
Okay, Mike, you're gonna have to take control while we switch over. Are you ready?
I'm ready.
First Officer Fagan must now hold the yoke steady as Captain Guy relinquishes control of the plane.
I have control.
Any mishandling of the controls could send the plane into a fatal spin. The same delicate balancing act transfers control of the plane to Captain Hansen.
I was pretty appalled at how much force it took to fly this big, beautiful airplane. If the airplane is flying, even lousy, it's flying. And that's the bottom line. And it's headed towards Anchorage. So we're good to go for a while. Now we could begin to devote some thought to other things that had to be done.
The crew has no idea how badly the rudder is damaged. It could be seconds from tearing off altogether.
I can't tell whether the damn rudder's trying to leave the airplane.
What do we tell the cabin?
We decided the passengers really should know, so we wanted a liaison with the cabin, and Frank offered to do that.
I'll go back and tell them. The more they know, the better.
I agree. I think we should tell them exactly what's going on.
Kathy, we don't know if things are going to get better or worse.
Every single crew member knew that something major had happened to that aircraft.
We've turned back to Anchorage and we're going to make an emergency landing.
The captain didn't try to hide anything, didn't try to pull any punches. He just flat out said how things were and that it could possibly be a very rough landing.
Kathy, we're calling this one a red emergency.
Red emergency is, of course, preparing for the worst. There may be a crash landing, there may be damage to the aircraft, there may be injury and or death to the passengers and or yourself.
Hello, ladies and gentlemen. I'm Captain Frank Gieb. We are dealing with a malfunction at the moment, and our crew is dealing with the situation as best we can. We need everybody to remain calm. And please, give your flight attendants your complete attention. I cannot stress how important your complete cooperation will be in order for us to make it to the ground safely.
The passengers, for the most part, were fairly calm.
I promise I'll update you with any new information as it becomes available. Thank you very much for your attention, and I'll talk to you later.
After a few minutes, you could hear some people crying a little bit. You could see people looking around. You could see fear.
We need to talk to SOC. We need suggestions.
We can reach them on HF.
The Systems Operations Center in Minnesota may be able to help. But to reach that far, the pilots must use high-frequency radio, which has a weak, intermittent signal.
HF radio is like when you were a kid and your best friend lived next door and you talked to him between your bedrooms with 2 Campbell soup cans with a string between them. About that level of sound quality is just awful.
And ask them to wake up John Doherty for us.
I was at home the night of the call, just relaxing after a day in the office, enjoying a movie, but I was on call. And those pagers would go off, and sure enough, it did.
John Doherty has worked with Captain Hansen for several years.
I knew John very well, so I had a face, a person, a pilot I knew very well in my mind's eye.
I knew John Doherty had a better knowledge of the 747-400 than anybody at Northwest.
But Captain Hansen has no idea when his friend's help might arrive. And keeping the huge aircraft flying level at 35,000 feet is becoming increasingly difficult.
The control wheel was shaking because the whole airplane was shaking.
He decides to descend to a lower altitude, where denser air will provide more lift.
You ready to do this?
All set.
But with a crippled plane, this normally routine procedure will be another risky maneuver.
Okay. Let's go.
You want to do it very carefully. So they're handling the controls under this really unusual circumstance as carefully and gently and as delicately as they can.
How's it feel? About the same, not great.
We had to be very careful how we flew this airplane. The tail might be coming apart. The rudder might be just barely hanging on, or it could be a hydraulic problem.
28,000.
They make it down to 28,000 feet without further incident.
I think I got this here.
Okay.
But the force required to fly the damaged aircraft has taken its toll on the captain.
John.
Yeah, my leg's starting to cramp up. I'm having a tough time holding this together.
The physical effort that was required was considerable. We were pushing so hard with our leg on that rudder pedal that we could only do it for about 10 minutes.
You're gonna have to take it. Are you ready?
I'm ready.
All right. Nice and easy.
And then Mike would come in as I released.
It wanted to go back the other way. In other words, you had to make it go where you wanted it to go. And you have to use the cross control. So you're using the muscles in your shoulder and in your back, and we would lock our legs.
And then when I would release, I'd kind of get limbered up again.
Still more than an hour away from anchorage, the flight attendants prepare the cabin for a red emergency.
We did what we were trained to do. It just kicked in, and you would make sure that everything on the counters put away, make sure all the crew bags are stowed and where they should be. Everyone, to a person, cooperated with what we asked them to do. I remember coming to a family of 3, and they asked me if I was afraid. And I hate to admit it, but I did briefly consider lying. But then I decided that wasn't what I should do.
Yeah, I'm afraid too. But we have the best pilots.
Flight 85, we have John Doherty on the line.
Operations has finally been able to connect the pilots with John Doherty.
John, have you been briefed on this? You know what's happening up here?
Yes. I understand you have a control problem?
ICAS is showing we have a hard over lower rudder.
They were facing really a very confusing situation. They knew they were confronted with something unique. It was something that they had never done in training, something they had never seen in training, nothing we'd ever talked about in ground schools.
Tom is not telling us much. We're an hour out of Anchorage. What do you think?
Well, don't remove any power
from the hydraulics. But other than that...
And I knew from listening to John that what we had in the books wasn't going to be a help to him. There are going to be some circumstances where a pilot is going to have to figure out what to do on his or her own.
30 minutes pass before Northwest 85 is in range to talk to the Anchorage Control Center directly.
Northwest 85, we have you on the
Radar.
Anchorage, Northwest 85. Confirm
That you are aware that we have declared an emergency.
that you have emergency equipment standing by.
We will request runway.
The plane must fly over the Aleutian Mountain Range to reach Anchorage International Airport. The airport itself is also surrounded by mountains.
We said, okay, 6 right is the runway we want because it'll give us a 20-mile final, and it's a great runway with an ILS approach, and it's long.
Okay, 6 right it is. Let's make sure we get it right the first time.
As far as the missed approach is concerned, we're not going to do one. We're just going to do it right the first time. We're going to put it right on the spot.
There is no margin for error. The pilots know they have only one shot.
What do you think, Mike?
Maybe we should start configuring for landing early. Lower our altitude.
They're still 40 minutes away from Anchorage, but the pilots decide to configure for a landing. They want to see how it will affect their crippled plane. If something goes wrong, this may give them more room to recover.
Okay, we can take it over Cook Inlet, lower to 14,000, and then see what happens.
14,000 feet is a real nice intermediate altitude. It's good, thick air, and it's high enough yet that if something got worse and control deteriorated, you'd have room for a recovery.
This is Northwest 85. We would like to descend to
14,000 over Cook Inlet.
We can't do that. Lots of air traffic in that airspace.
The airspace over Cook Inlet is the busiest corridor in this part of the continent. If they lose control of the plane again, they could collide with another aircraft.
This is an emergency aircraft. This is
the safest course of action.
okay.
We'll clear everyone out of your way.
The jumbo jet slowly descends to 14,000 feet.
Okay. Flap 5.
flap 5.
As he adds flaps, Captain Hansen can only hope the plane maintains stable flight. Next comes an even bigger test.
Gear down.
Gear down.
Lowering the massive landing gear will increase drag and reduce airspeed. The plane handles the new configuration without any problems. But there are new worries about the damaged rudder.
You feeling that?
Oh, yeah.
The rudder is tied to airspeed and altitude. The lower you get, the further the rudder goes out. So then it required more rudder, more aileron, and that was physically exhausting.
Mike, my leg's starting to cramp up. Are you ready?
I'm ready.
John Doherty is still on the line to the crew. He offers a suggestion.
Have you considered adding
20 knots to your approach speed?
No, we hadn't thought about that.
We'll do it.
The extra speed may help make the plane more controllable.
Hello, ladies and gentlemen. We're in for a bit of a rough landing. When we touch down, there's going to be quite a jolt. We'll tell you when to brace for impact.
As Northwest Airlines Flight 85 approaches Anchorage, the pilots and Doherty continue planning for an uncertain landing ahead.
We discussed how are things going to be as we fly the approach, what flight control, what management issues in terms of flight path we're going to encounter there, and then how are we going to manage directional control during the landing rollout, what stopping issues we're going to have, and so on.
The decisions they face in the next few moments will make the difference between life and death.
Okay, we can't do this anymore. Let's use the engines. Dave, get on the levers. 1 and 2 up, 3 and 4 down.
Just minutes from touchdown, the pilots increase power to the left engines while reducing power to the right. This uneven thrust should help keep it straight. But there is a danger. No one knows how badly damaged the rudder is. If it tears off while the engine thrust is uneven, the pilots will lose all control. On the ground, they are preparing for the worst.
Give $1,000 for a rearview mirror right now. John, what do you think?
Doherty has been scouring charts and manuals. He reminds the crew of another problem to consider.
On landing,
Don't forget the rudder's attached to the
nose steering.
And when that happens, Mike, I'll take the tiller and the brakes. You take the yoke.
Once the nose touches down, the damaged rudder may cause them to lose control of the plane at more than 300 kilometers an hour.
I flew the approach all the way down, and I thought, if there's ever going to be a time that you fly a perfect approach, it's got to be this one.
I became extraneous at that time, so somewhere along around 7,000 to 8,000 feet on the way down, I signed off with the crew.
I'll talk to you when you're on the ground.
We'll talk soon.
You know, I gave John whatever blessing I could give at the moment, probably understated in typical pilot fashion, and I was off the line and just waiting to hear what happened.
Between the frigid waters of Cook Inlet and the towering Alaskan mountains, Anchorage International Airport awaits the arrival of a stricken 747.
Northwest 85, we have you on our radar.
The passengers and crew of Northwest 85 are now moments away from an emergency landing.
As I was putting my own seatbelt on, I remember thinking to myself, is this all there is? As in, am I done here? Am I going to be alive when this is over? And I thought about my kids and my husband and my home.
Northwest 85, clear to land. Emergency equipment standing by.
Roger, cleared to land.
The crew still has no idea what will happen when the plane touches the ground.
There were close to 400 passengers in that airplane and a crew of 18, and some of them people that I knew personally, like John and the other pilots in the crew, so waiting was hard.
Okay, everyone, here we go.
Touchdown in 5.
Prepare for impact.
Brake! Brake! Brake!
Got it? I got it.
As planned, on touchdown, First Officer Fagan takes the control column. Captain Hansen guides the front wheels with the tiller. The timing is critical. One false step, and the plane could shoot off the runway.
We got it. Good job, Mike. Good job, guys. So what do we do for encore?
Not that.
Everyone in the cockpit was finally able to exhale, and we just went.
Once we were given the signal that it was okay,
Please remain seated until the seatbelt light is off.
I knew that I had to get up and go to that entry door and get these people out of this airplane. We did what we were trained to do. We did a great job.
Controllers can see what the pilots can't.
That's quite the rudder you got there. Must have been a hell of a ride.
Oh yeah, it was a real joyride.
Almost 2 hours after the emergency began at 35,000 feet, all 404 people on board are safely on the ground.
Well, when I heard the crew was safe, of course, it was an incredible sense of relief. These guys had been tested, and they'd done a fabulous job. So, you know, it was really joyful. I mean, a sense of grace, accomplishment, joy, satisfaction. It was all good.
The pilots have narrowly avoided a fatal crash. But what caused them to lose control in the first place is a question that desperately needs to be answered. Northwest is just one of many airlines flying the 747-400 every day. Thousands of passengers around the world now face a potential risk. Carolyn DeForge of the NTSB will oversee the investigation.
It appeared to be a very dramatic event, and it definitely seemed like something we needed to follow up on and try and understand what had happened.
Investigators immediately discover a trail of hydraulic fluid leaking from the back of the plane.
It was very surprising to us when we found out what type of failure had occurred and that the effects it had had on the aircraft's controllability.
The pilot's foot pedals are linked to the rudder through a hydraulic power control module, or PCM. When the pilot presses on the pedals, the PCM changes the hydraulic pressure, and that's what moves the rudder.
They opened up the access panels in the tail, and they noticed that the end cap on the control module had separated. The end cap is a circular piece about 2.5 inches in diameter, and it had completely fractured all of the way around its diameter and had then fallen off.
With the PCM broken, the pilots had no way to control the lower rudder. The failure of this one piece of engineering nearly brought down the entire plane. The power control module is shipped to the NTSB headquarters in Washington. Close examination reveals exactly how the failed part caused the rudder to jam.
When the end cap came off, it allowed a piston inside the module to move further than its design limit was intended, and that is what resulted in the rudder hardover.
But why the module's end cap failed in the first place is still a mystery.
It was certainly something that was not anticipated by the designers, and when we examined the hardware, it was definitely beyond the scope of what you normally encounter as an engineer when you're doing a failure investigation. Normally you see something that's an internal failure, not an actual mechanical failure of the housing itself.
Sylvie Dion is a metallurgist specializing in airplane components.
The manifold material was an aluminum alloy, which means that it's actually aluminum metal that's mixed in with a bit of copper, with magnesium, with zinc. And the purpose of adding these other elements is to make it stronger.
The aluminium alloy used to make this part is extremely resilient. It should never break apart like this.
Doing failure analyses like this on failed parts is a bit like being a detective, because you're looking for clues as to what caused the occurrence, what caused the material to fail.
The size and shape of the crack tells investigators that the module wore out over time, what's called metal fatigue. However, this is almost impossible for them to believe. A Boeing 747-400 is built for long hauls, 12 to 15-hour flights, and its parts are built to last decades.
My understanding was the mean time before failure for this item was something like 30,000 years, which is basically saying, well, we don't think this part was ever going to fail.
The 747-400 is in high demand. More of these massive planes are being manufactured every year, with the same control module that failed on Flight 85. If this crucial system is wearing out prematurely, investigators need to figure out why, before it leads to a fatal disaster.
The fact that this had a purely fatigue failure with no apparent origin to it such as a deficiency or a defect, made us question the material properties of the housing itself.
Investigators send the unit back to the manufacturer for extensive metallurgical testing.
Metals are made up of little crystals, which metallurgists call grains. And if the grains are too small or too large or not the correct shape, the material may have a different strength, different ductility, different resistance to propagation of a crack.
A visual examination of the metal provides no insight into why it failed.
One of the best techniques for revealing if a part contains cracks or surface defects is to use fluorescent dye inspection. The part is examined under UV light, and the defects will appear as bright lines or bright dots that are very visible.
But the exhaustive tests reveal that the material itself was not to blame. Investigators still can't explain the failure.
It was driving all of the group crazy. We were very frustrated when we realized that all of the paths we chased down didn't give you that aha, eureka moment.
Investigators wonder if something in this plane's history could have caused the module to break down prematurely. What the records reveal is surprising.
Northwest was the launch customer for the 747-400, and this one was the first in the line of 400s that Northwest flew. It was the oldest production 747-400 in the world.
And that's not all. Records also show that this very 747-400 was used as a test plane before it was even sold to the airline. Could rigorous testing have somehow led to the failure of the power control module? The plane had flown for 55,000 hours and taken off more than 7,000 times. That's more takeoffs and landings than most 747s with that number of hours in the air. This discovery leads the investigation in an entirely new direction.
We were concerned that it had been exposed to more stress than we had expected, and that may have caused it to fail.
Each time a plane takes off and lands, its systems are put through more stress than when it's simply flying through the air.
We were very concerned about those operators in Asia that use the 747-400 on short-haul flights.
This module, however, is already broken. There's no way to test it. Checking all the units on the rest of the fleet is not a practical option.
You would have essentially had to have grounded the fleet to remove all of the units.
As a preemptive strike against future failure, the NTSB recommends that airlines test the power control module more vigorously and more regularly.
We instituted a repetitive inspection cycle requirement.
But the root cause of the failure is never found. 4 years later, an Air France cargo plane is forced to make an emergency landing. Once again, the lower rudder has failed on the 747-400. The circumstances are strikingly similar to Northwest Flight 85.
The unit was sent to Parker Hannifin in California for repair, and when they opened the box and looked at it, their eyes got really big. They immediately quarantined it and called everyone and said, "Oh my gosh, you're not going to believe what just showed up on our doorstep."
If the Air France module shows signs of metal fatigue like the one on Flight 85, then investigators may be a step closer to explaining the mysterious failures.
We immediately focused in on the fracture surface again in the same area and did many of the checks that we had done the first time around.
But this case seems to be different. There is no sign of fatigue. Instead, they find a manufacturing defect.
We actually found a deficiency in the bottom of the threaded bore section. We found a very sharp radius at the bottom of the threads, which is where the crack had propagated from.
While finding the cause of this latest failure is significant, it has done nothing to help explain the failure on the Northwest flight 4 years earlier.
Was it overloading? Was it a progressive failure? Was it exposed to something in the environment that caused it to fail?
Without knowing the why, you can't really take the appropriate corrective action. And as an investigator, that's frustrating.
For the second time, a part that was never meant to wear out has nearly brought down a 747. With one of the two near tragedies still unexplained, investigators desperately need to find a fail-safe measure that will protect passengers in the future.
Okay, everyone, here we go.
4 years after Flight 85's heart-stopping emergency landing in Anchorage, the cause of the 747's rudder failure is still unknown. Now the same part has failed on another flight. The next failure could be deadly.
We still don't know actually the root cause of the Northwest failure. But because of what we found with the second Air France failure, we needed to take corrective action to prevent similar failures from occurring.
Investigators recommend attaching special plugs to the control module. In the event of another failure, these new pieces will prevent the rudder from moving too far in either direction.
The changes that we've made to the control modules in the 747-400 fleet will prevent any future events of a rudder hardover.
An airworthiness directive from the FAA makes it mandatory for every 747-400 to be fitted with this new technology, eliminating the risk of another failure. But still, there is another question to consider. One investigators seldom have the luxury to contemplate. With a catastrophic failure of the rudder system, why didn't Flight 85 crash? One reason: the very design of this 747.
Having a split rudder is definitely an unusual feature of this airplane. And in this case, it worked in their favor in the sense that if there had only been one rudder and the actuator of that rudder had failed, then 100% of the yaw control would have been deflected, which would have magnified the problem.
But technology alone did not save 404 lives. In 1985, China Airlines Flight 006 also went into a sudden roll. But that flight plummeted nearly 30,000 feet before the pilots were able to regain control. How had Flight 85 escaped the same fate?
If Frank hadn't reacted the way he had, we probably would not be here to tell the story.
Frank, have you got it?
Yes, I think I've got it.
Captain Geib's actions in the first few seconds were critical to saving the plane. But what got it safely to the ground is another story.
Every pilot in that cockpit knew what was going on. Risks were being assessed and so on.
On landing.
Don't forget the rudder's attached to the nose steer.
And when that happens, Mike, I'll take the tiller of the brakes and you take the yoke.
Cockpit resource management is really what enabled us to think this thing through and get the airplane on the ground.
I am proud to say we were like a well-oiled machine. We all did what we were trained to do.
Touchdown in 5. Prepare for impact.
And not one single person fell apart.
What should we tell the captain?
Guys that we had in the cockpit were just tremendous. Everybody communicated.
I'll go back and tell them. The more they know, the better.
I agree. I think we should tell them exactly what's going on.
I think this crew did a phenomenal job in getting this aircraft back on the ground safely.
In 2003, the Airline Pilots Association awarded the crew of Northwest Airlines Flight 85 with the Superior Airmanship Award.
More important than the award was the fact that we got the people on the ground safely.
We got it.
In this day and age of automated cockpits, hand flying is in danger of becoming a lost art. We have to remember as pilots that we are there because of our flying skills. We had prepared so well for this thing that failure was not an option.